Hello and welcome to the 9th seminar. Today we'll be talking about me. This is quite handy as I can't do that many mistakes. The seminar number 8 won't be available on YouTube as I didn't held it. It was another member of the Discord server and let's get to it. This presentation was because of many questions on how I got into nuclear chemistry, and that's the topic for today. Currently, I am 22 years old. My name is Simon. I started learning about chemistry at age 14. I really wasn't that hooked on chemistry as we were learning about how to extinguish a fire and mixing water, salt and sand and stuff, really boring. But a year later, at age 15, we started learning about the structure of the atom, and I was really hooked on astronomy and nuclear physics and stuff like that. And since I'm not that good when it comes to mathematics, I decided to stick to chemistry rather than physics. I still really like physics, but yeah, I got really hooked on chemistry at age 15 when we started learning about the structure of the atom. I finished A-levels with an average grade of 1.9. Just a quick summary of the German education system. It starts at age 6. In the elementary school, first grade, you will finish elementary school at age 10 in the 4th grade, after the 4th grade. And depending on how well you did there, you will be categorized into different school groups. So you have, for the best students, you will have the gymnasium. I found that the translation high school would fit the best. And yeah, there are some other. I went to the gymnasium, so the high school. You will start there at the 5th grade and will finish it in the 12th or 13th grade at age 18. And yes, you finish high school with an exam called the Abitur, or the translation is the A-levels. Just to give a context for this grade, you need a bare minimum of 4.0 to pass, but if you are literally perfect, you can get a grade to 0.7, but a 1.0 is literally perfect. I wasn't that perfect, but it's still a good grade for A-levels, in my opinion. It all depends on what you want to study later. So if you want to study medicine, you need at least, I think it was 1.2 or 1.0, depending on where you want to study it. When you do your A-levels, you have to choose, in the part where I live, 4 different subjects to do your final exam. I chose chemistry in German as advanced courses, so you will learn pretty much the same as in the normal courses, but in a bit more detailed fashion. And I also had to choose geography and English as normal courses in order to write my A-levels in it. All right. After I finished high school, I started studying at the University of Cologne and the Deutsche Sporthochschule, or German Sports University, since my aspiring degree is the Master of Education, a teacher for high school in chemistry and physical education. I like chemistry, I'm quite good at chemistry-ish, and I also do a lot of bouldering, and I like doing sports, so physical education it is. So I am not a chemist. I am going to become a teacher for high school, right? Not a real chemist. Yeah, as a teacher, you need at least 2 subjects. In my case, it's chemistry and physical education. When you study to become a teacher, the chemistry part is way more easy than doing actual chemistry. In my opinion, it's the sandbox version of chemistry. Since it's way more easy, you will also learn way less about chemistry. So normal teachers, they don't learn the stuff that I present here on YouTube. Currently, I am in my 2nd semester of the Master of Education at age 22. Normally, you should be able to finish it within the 4th semester, but I will take my time and do a 5th semester because of YouTube and stuff like that. And after that, you could either go into school, or you should go into school for 1.5 years. And after that, you are officially a teacher in Germany. But who knows, maybe I can make this YouTube thing a whole-time career, but maybe I can become a teacher or I do a PhD in nuclear chemistry. Who knows? I think I like the thought of staying at the university for a bit longer. Yeah, talking about nuclear chemistry. This is how I got into chemistry. Now, talking about the nuclear chemistry. I am an element collector. Since I finished high school, I have a collection of several elements right above my PC, and I always wanted to see technetium as it's quite rare. And I asked my professor if I could see technetium, and he wrote to the working group of nuclear chemistry. And I saw technetium for the first time. I saw neptunium for the first time, radioactive cesium and uranium and thorium, all of the good stuff. And I wanted to learn a bit more about technetium. And then I found out that we have a whole lecture about technetium, and I attended that because this is some information that is not available on YouTube yet. And at this point, it was quite clear that I wanted to write my bachelor thesis in there. This is the final project after 6 semesters in your bachelor program. And after that, you will start your master's program. And I also attended the practical course in my free time because I wanted to learn how to work in a nuclear lab. Yeah, all the experiments that we do will end up here on YouTube, and some of them are already on YouTube. And then I wrote my bachelor thesis. So it really was that easy as just asking, can I see technetium? And that's it. It really wasn't that fancy. Just study at the correct university, I guess. So what did I do at my bachelor thesis? I extracted potassium 40 as potassium carbonate from bananas. I extracted radium as radium chloride, or barium, radium containing barium chloride from Brazil nuts. And I extracted polonium-210 from tobacco and polonium-210 from uranium ore. I did a video about this on the YouTube channel. I also did about this. And also about this is something that will be done in the future. And yeah, my whole bachelor thesis project was to create a school-friendly way to introduce nuclear chemistry back into schools, but according to our very strict German radiation protection laws. So this was really a challenge, and I focused on extracting naturally occurring radioactive elements out of plants. The uranium ore thing was just a nice add-on that worked way too well. Okay, and I started doing YouTube videos to help my own lectures as a chemical tutor for my pupils. And I wanted to show them all of the reactions that we discussed during this lecture. And then I also wanted to show other university students how their experiments should look like because of Corona. We didn't get to see that many experiments. And yeah, it's also really annoying if you do an experiment and you kind of forget to write down your observation and you don't have a video about it. So now we have videos about the experiments. Yeah, this is quite a handy help. And coming to the aspect of nuclear chemistry on YouTube, learning about nuclear chemistry is really difficult because find a reliable source on the internet or even books are rare. I think the book I have here is not even available in German anymore, even on the secondary market. And for most people, this is also why I think I have the job as a tutor for chemistry, is where do you even start? Like normal chemistry, you can learn on the internet if you want to quite well. You just have to structure the learning process. And there is no one to structure the learning process when it comes to advanced chemistry, so university type chemistry, or even then going further, the nuclear chemistry. And I wanted to help with that because I already have this structure made by the university, and why not introduce it to everybody, right? The special part about this YouTube channel is, of course, my allowance to film inside of a nuclear lab, because filming inside a lab is already difficult enough, and filming when handling radioactive stuff at the same time, really difficult. And most of people don't know what a nuclear lab looks like from the inside, because why would you film stuff? You do research normally, right? This is, for example, what some of these videos look like behind the scenes. Just to talk about my German channel, because this is a video that is on the English channel exclusive. I have 5 formats on the German channel. So Chemistry at Home, where I focus on having just chemicals that you might get at the hardware store or at the grocery store, and not with fancy lab equipment. I also have the school chemistry, specifically made for students at high school and stuff like that. For example, the chemistry of Minecraft, where I talked about chemistry-related topics that are found in Minecraft. Why not? I also have the university chemistry, so anything that is beyond high school level chemistry, but which is really important when it comes to university, which is not radioactive, because for radioactivity I have a separate format. I also have the chemistry for biology, so this is with the focus for biology teachers who want to create their lectures a bit more interesting with experiments, because most biologists don't have that many experiments to work with. And of course, we have the nuclear chemistry. For example, this is a video about cesium-137 in German mushrooms. Yep. And the future for the YouTube channel is is quite interesting. Anything that I will mention here will be first uploaded on the German channel, but will also end up on the English channel, so don't worry. I have already planned a video about fluorine-18 chemistry and the cyclotron and astatine research at the research facility in Jülich. Also, we were planning on having a video about how to make uranium hexafluoride, the stuff where you enrich from. At the moment of recording, I already did that. I just need to edit this whole video. And more of the collaborative work within the university because, well, nuclear chemistry is not nuclear chemistry exclusive. Radioisotopes find their application also in biology and dating meteorites and some other geology stuff. And a bit more about the AMS, Accelerated Mass Spectrometer, which is a device that we are quite proud of, and some far future projects that are not specifically planned are videos at the Karlsruhe Institute for Technology, the KIT, and some other radionuclide productions. So I also wanted to see where does the phosphorus-32 comes from when we hit on the just purchase now button, and maybe some transuranic element research if I could get my hands onto that. With that being said, thank you for your attention and goodbye.